In this video, we're going to talk about the conic section hyperbolas. So a hyperbola is formed when the geometric plane intersects our cone through both of the naps, and it gives us these two different curves. So both of these curves are part of the same hyperbola. So these curves look very similar to a parabola, but there's two of them, and that makes a hyperbola. So we have to look at a few key features and vocab terms when describing hyperbolas. So there are two different axes that we talk about when we're talking about hyperbolas. There's the transverse axis, which is the axis that goes through the center, the vertex, the transverse vertex, and the two foci. So just like with an ellipse, there are two foci in a hyperbola. And then we have the conjugate axis, which is perpendicular to the transverse axis and goes through the center. The conjugate axis is used to help us kind of determine the width of our parabola. And then we have we actually have oblique asymptotes here. So we have this asymptote and this asymptote. And we actually, to determine the slope of our asymptotes, we use the values of the distance from the conjugate axis vertex and the transverse axis vertex to the center to create this kind of box. And our asymptotes are going to go through the diagonals of this box. So let's go ahead and talk about these different values. So the distance from the center to the vertex here, this transverse axis vertex, that distance we call A. And the distance from the center to the conjugate axis vertex we say is B. And the distance from the center to the focus is C. Now, in this case, you can see that the value of C is longer than both A and B, and that's always going to be true. And we can see that the focus is always on the outside of our vertex. It's not in between our center and our vertex. Our vertex is in between our center and our focus. Unlike in the ellipse where the focus was in between the center and the vertex of our curve. So the relationship that we have for A, B, and C is actually just what we know from the Pythagorean theorem. So it's A squared plus B squared equals C squared. And we can actually create a right triangle here between these values. So we have the distance from the center to our transverse axis vertex. And then we have the distance from the center to the conjugate axis vertex. And then we have this distance here. So this diagonal distance is actually the same as the distance from the center to the focus. So this is just the length of C, which I think is pretty interesting. So A, B, and C. A is again the distance from the center to transverse axis vertex. B is the distance from the center to the conjugate axis vertex. And C is the distance from the center to the focus, this distance here. So what do the equations of hyperbolas look like in standard form? So if you have a horizontal hyperbola, the standard form equation is going to look like this. It looks very similar to an ellipse equation, except the sign between our two groups is actually subtraction. So we have the quantity x minus h quantity squared divided by a squared minus the quantity y minus k squared divided by b squared equals 1. Now, unlike the ellipse, a is not always the bigger value, so we just call the first part a. So the first denominator's value is a squared, and then b squared, and then you notice here a squared and b squared. So the values of a are not what determines where our transverse or conjugate axis is, but rather what determines the transverse and conjugate axis is which term is in front. So we can see that in this case we have the x group in front of our difference, and then that gives us a horizontal parabola because then we can say the transverse axis lies along the x. And then in this case we have the y grouping leading our difference, and we can see that the transverse axis is going to lie along the y-axis. So both of these hyperbolas have asymptotes. So in the case of the horizontal hyperbola, it's going to be y minus k equals plus or minus the value of b divided by a, all times the quantity x minus h, where h and k are just the values of our center, and then b and a are the same b and a that we get from these. The only difference between the asymptotes in a vertical hyperbola is that the values of a and b are switched, so a is the numerator and b is the denominator. And these are the equations of hyperbolas in standard form.